Okay, so hello everyone. This is Ray Lutz with Citizens Oversight, and it is Cinco de Mayo. Happy Cinco de Mayo to everyone. And what we had to start with here, and I think it's some good questions about the risk limiting audits and how much they cover. So this first question, let me get this larger. Is there general agreement that the risk being referred to in RLA is a risk of having the wrong person elected? No, that is not what the risk is that they talk about in RLA, but they like to act like it is. And so the actual risk in the literature there is only the additional risk that is due to sampling. And if you had that risk at zero, there's still many hazards that the thing is not correct. So, and I wanted to go over this chart that I made, which kind of goes over all of the different things that could, what we would be working with. And I made this for a trade show kind of a get together, and but it was far too detailed to really go through. And I'm not going to expect to go over everything here, but basically just to bring out some of the issues that are an issue here. So there's registration. There can be malicious purges or changes to the database. There can be early deadlines to try to keep people from voting. Those are sometimes. And all of these things with the registration scams can be mitigated with same-day registration. That eliminates the deadline issue and the purges because people can always re-register. There's also this thing called ERIC, which is the Electronic Registration Information Center. And they actually develop a big, essentially, database in the sky, which has everybody listed, but is secret, right? And so the officials can send in their list and find out if somebody has moved to another state, for example, and so that they can take them off their voter list. But also it actually works the other way as well. When those people move to the other state, they are notified that this person just moved in and please add them to their voter roll. At least ask them if they want to sign up. So it actually is not a purging effect. It actually is more like a getting more people to vote effect when they do this right. Now, then you have polling location access scams, last minute changes, too many voters and long lines, right? So there's scams around this too. So that's number 2, which is the polling place. We have 3, voter validation, signature comparison. Sometimes it's difficult to obtain the IDs that are required, or the signatures aren't compared right. Then you have polling list errors, that's up here. A list of voters who voted, issuing ballot errors. What's that, number 4? Where's 4? Here we go. So no, 5. Issue the ballot. Did they get the right ballot? Sometimes if they make it hard, you've got to ask for the right ballot. If you're nonpartisan, you need a Democratic or Republican ballot in order to vote, and they don't tell you that, and then you get the wrong ballot and so forth. So they can make that hard. Correct ballot availability. Did they have the ballots on hand for you to vote with? Okay. Then marking errors, voter intent. So 6 is one of the things that would come out later in the tabulation potentially. But did they just make a mistake? Did they, the butterfly ballot concept where it was listed over here and it looked like they should do that punch, and it was by the other person's name. And so this would be mistakes that were made that you could not detect later. Use of unreadable barcode, so we can't validate it. Confusing ballot design, so that people are confused and they make mistakes. 7, The scanner review like misdirection. So the scanner could, after they submit the ballot, the scanner could say, you know, you voted for this, and then get them to say that's okay when in fact they didn't vote for that person. Okay, so then security, that's number 8. The cast ballots, then are either they're a marked ballot that hasn't been scanned yet, or it's one that went through the scanner and they're casting it. Now we have security of these cast ballots. Were they secure? Now, if you're in the precinct, or if you are, if you're in the precinct, or this is if you're in central count over here. So this vote by mail, we have the signature comparison, and we have 8 here, whether they're secure, they open the envelope. And now both, whether you're in the precinct or in the central count scanner, they create ballot images, and there could be manipulation prior to creating the cast vote record right here. So it's a little bit higher risk in a commercial off-the-shelf scanner, because in this scenario, because they use drivers that you could potentially get to. In an embedded system, it's pretty hard to do. You have to get into that embedded system and change it, so you could change the ballot image. It's really not that easy to do. Then here we have the CVR, the cast vote record could be modified and mismatch, or malicious changes. This is where you would have something like the fraction magic happen, where you actually modify the cast vote record directly here. Now we're going on to having the 11 paper ballot security after scanning. It goes into a secure box, and the images go into thumb drives. There's need to be security there, or and we need hash codes to secure them. Then we transport the box to the central office. That was still 11. And then we have secure paper ballot storage, still 11. The ballot images on thumb drives, that still needs to be secured. Ballot images are combined into zip archives, and then this should be way more than 2 gigabytes max. We combine the cast vote record and we post this. So finally we get to a posting time here. And now we're down in here to the tabulation process. I believe that's this one. So we're repeating this part up here at the top. We finally get into having these hash codes and everything in this, but we create a ballot manifest. We choose a random seed. We pull random samples. We generate random sample IDs. We get samples. We manually tally them and calculate the risk of the samples, calculate risk limits, and then we have the audit report. So if you think that risk limiting audits are error-free, look at all these steps. There's a lot of steps here that have to be done without mistakes inside of the audit itself. You want an audit process that's not too complex, because it's hopefully the process you use to audit something is simpler than the thing that you're auditing. Otherwise, you need yet another thing outside of this to test it. So paper ballot review audit hazards. You can defeat the audit if the ballots are modified, added, or deleted prior to scanning. So that's true in any case. Okay, for any of these audits, if the paper ballots are modified, added, or deleted, brought in suitcases and all the stuff that you've heard about, all of the the things that we've heard in this election, especially about the bamboo paper and things from China and all that stuff, would haven't been proven at all, but still we're talked about. Then if the ballots are modified, added, and deleted after scanning, but prior to sampling. So if we did the scanning and they're sitting here in ballot storage and they get modified there, that's still a possibility. And you would say, well, we're going to go with what the paper ballot said instead of what the cast vote record said. It was wrong. Well, no, because the ballots could be modified. And all they have is a simple lock usually on those doors. The cast vote record could be modified. All right. That is what happens with this cast vote record. This is what you want, the cast vote record and all the adjudications prior to going into the RLA process. That could be modified too. Random, you would do, if you wanted it to not raise any eyebrows, you could, wouldn't necessarily do it to modify just the cast vote record, but it could be. Then you have a random sample generated. Usually this is not done right. They usually don't do random sampling right. It's usually a system that sounds random, but isn't. That's what they did in Arizona. So in Arizona, what they do is they choose the random samples ahead of time. They mark each one as this one's audited, this one's not audited, and they get 52 of them, and they choose half of them randomly. So the ones that were initially chosen were not randomly chosen. And they're all marked as to which ones are done. That's exactly the wrong thing that you should do. You should not ever tell your people working on it which ones are going to be audited, because then they know. And they can easily just manipulate the ones that they know are not going to be audited. Okay, so one thing that you can do with RLAs is you can always draw samples to avoid the hacked samples or in favor of the option that is there. So there's two kinds. There is the ballot comparison audit, and in a ballot comparison audit, you're comparing the ballot to the cast vote record to see if they line up. Well, if you only choose ballots that you know line up, then you'll never find the ones that don't. Perhaps easy to determine that. If you're comparing the margin of victory and you just choose the ones that are in, that buttress whatever the hacked result says, then it's going to just look even more like the ballots are in that way. So let me make that clear. So let's say there's some fraudster. He goes in, and we'll assume, like in this last one, Trump really won. So they went in and they changed the cast vote record so that Biden won. And then when they choose ballots for a polling audit, they only choose, or they mostly choose ballots that have Biden shown. And in their result of their audit, it says Biden won by a lot. So, that says that it's correct. These audits don't provide an error if the audited samples are too good, or it's look like that. There's no way that could be. They don't do that at all. They just stop early and say, well, we have enough evidence now. So anyway, they're fairly easy to hack the audit itself if you have fraudsters involved in conducting the audit. The ballot manifest could be manipulated to avoid hack samples. The manual, okay, what's that mean? Well, it means that let's say you know that all the even boxes were hacked, and they choose one that's odd. You just go over there and switch the label on the boxes. Now this one is, this is the one that you're going to audit, and that's the other one that you're not going to audit if they just have labels on the boxes. So we have that as a possibility where they're changing where these things are stored to get you to go to the ones that are not hacked. Then the manual tally itself and data entry can be incorrect, or they can do what I call innocent fix-up, which I've watched them actually do time and time again. In LA, they would do this without any problem at all. They didn't know that it was wrong. What they would do is they'd say, here's the original cast vote record. This is what we think is it. Here are the batch that we're sampling. They add up the batch and it's not the same. So they run this back through the scanner, get a new report, throw that one away, have a new report, and now compare to the new report. It always matches. They say no problem. But it could have been that the original one was a hacked, version of the cast vote record, and they just don't even report on that. So that's sort of innocent. I call it innocent fix-up. It's not necessarily that innocent, but it may be they're just trying to fix the mistake they think in the audit itself, and they're not reporting on it. Or we have a direct DRE-like entry with no paper trail, which is what Arlo does. So then this could result in a full manual count. I've got no problem with that, but if the margins are close, we have to be aware of it. And it may confirm to hacked election due to sampling error allowances. Let's say you have a 5% confidence, risk. That means you have 95% confidence. It also means that 1 out of 20 hacked elections will be missed. But still pretty good. Now, we may not include all the contests, especially small contests. This is what we were mentioning in the email. It's very hard to include all the contests in these, and incomplete or inaccurate reporting is a hazard where this is what I found. I try to go read their darn risk limiting audit or the audit report, and they don't include all the information. You can't even tell what they did. They don't even provide the results in the report, or they don't post a report at all. And then, of course, there can be calculation mistakes. So this is, again, I see some more people have joined, so I just want to go over this really quickly in summary fashion. We just covered the list of all the categories of different types of election hazards all the way through. And we looked at hazards in conducting an audit, like a risk limiting audit. There's all these different steps. Now, what is the question was, does the risk limit says simply that you have enough samples such that the error due to sampling only is within a certain level. It does not have anything to do with all of this list of risks here, and it doesn't limit any of these risks here, although it will catch some of them if you do this whole thing right. So some of these will be caught, but most of them won't be, right? So most of these, such as a registration mistake or a scam on registrations, that's not going to be caught by a risk limiting audit or a ballot image audit. Polling location access, whether they've manipulated and made it hard to get there, that's not going to be checked. Voter validation, if that's hacked, that's not going to be checked. Polling list errors, no. Issuing ballot errors, no. Marking errors, yeah, some of these we will be able to check because those will be showing up, but not the ones where there's a confusing ballot design and the voter makes a mistake due to a confusing ballot. That's not going to be something that we're going to detect. Security of the cast ballot prior to scanning, we can't check that one either. Neither ballot image audits nor RLAs will do anything with this. Ballot image manipulation prior to creating this cast vote record. This is the one risk that ballot image audits have, and risk limiting audits don't. We have this one issue here. Additionally, everything else is still, both of them are not, comprehensive enough to cover all of these various things, whether the paper ballot is secure, whether the thumb drives are altered, the posting service, whether things are altered later, and then in this other thing, if you're doing a risk limiting audit, you have all these steps where some of them are really will defeat the audit completely. And one of those is the innocent fix-up, which is what Los Angeles was doing systematically every single time. And so that would basically cover everything up. Maricopa County, they do this bogus drawing of samples where it's not random. Not that one, it's basically this one, random sample generated too. So basically the way they're doing it, they tell everyone which ones are the ones being audited and which ones are not being audited. So in essence, to answer that first question, you see, between looking at all these different hazards, there's so many that are not checked by a risk limiting audit. They require that the paper at this point, the secure paper in the storage. So this is what risk limiting audits relied at this point. This is pristine. There's no problem with this. It's assumed that this is good. And in reality, just getting to that point, you have a lot of different risks here about things that could be incorrect. Some of these are things that can be rectified in other ways, you know, such as the polling location access, whether it's easy to get to the polls, whether they're all of a sudden changed at the last minute, people given, you know, emails that say their polling location has changed. That we changed the day, you know, of the election. We decided to change it by a week. Come next week instead. You know, all of these things actually have been employed to try to fool voters and to not get them to go to the election. The ones they don't want to vote, and the ones that they do want to vote, they don't give it to them. All right, so let's stop there. Any question about this part, this graphic? No hands coming up.
I have a question. I guess I should raise my hand.
Yeah, it's okay. Go ahead. No one else.
I think it is the presumed gold standard is the manual count, which of course is not perfect. So for it to be valid, you have to exceed the margin of error in hand counting.
Right. So that's a good point. There's a that would be on this other one here. There is a manual tally, and I guess which one is it? It's basically mistakes. Calculation mistakes or hacks. I mean, yeah. So it is actually, if you just have people doing manual tallying with no checks or balances or ways to control error, it's they say between 0.5 to 2.1% mistake rate. Now that's overall. So it isn't on a per contest basis, and so it's really smaller than that. If you have a lot of contests on ballot, then you know that if you made 2.1% mistakes and you had, you know, say 50 contests, those 2.1% are spread amongst those 50. So that means we'll make it 100. That way we can divide easy. So the 2.1 you would divide by 100. So it'd be down to, you know, like 0.021% per contest. So it's really not too bad. But if you're just tallying, as they do sometimes, just a couple of contests, like in Maricopa, and your error rate, if you're not careful, is 0.5 to 2.1, you're going to have trouble doing a 0.31% margin, which is what they were hunting for. And as a result, they had a really hard time controlling the errors in their audit process itself. There was no experience there, and in terms of what they needed to do was to check as they go. And I had actually it was a video here. Maybe I can show it, because I did between when I was talking to Paul about this, we were looking at the history or the auditing, the actual how they were auditing. And when they did the auditing in San Diego, they would have 3-member teams, and they would have one person read what was on the ballot, and then 2 people tally, and they would say like what the total was for each contest at the same time, to make sure that they were in sync with it, and their tallies were syncing up. Because the recording process is much harder than it's very easy to make mistakes in the recording process of the tallying. So the experiments in the universities, they found that error rate that I mentioned, which you could hold down if you have other systems, or maybe have 2 competing teams tally at the same time and compare. There would be a number of ways to hold that down. So let me see here. We had I thought I was going to be able to show it to you, but it's not in my list of history that's easy to pull out. So
Can you get down to 1/10% in a well-structured manual
yeah,
tally?
I think so. I think that you could, well, that's, a 1/10% is, I mean, it certainly is possible because, you know, you have to be able to, I mean, human beings have to be able to do it, right? We have to be able to look at this stuff and do it. But if it's a big thing like Maricopa County with 2.1 million ballots, okay, now this starts to, that 0.1% you're talking about starts to be, there's a lot of ballots to count there, and it's easy to make mistakes along the way, not include batches, other things like this, so that it's not just the error rate that they were testing in these tests, which was just the error rate of how you were marking it and tallying it up. That's one thing. There's also the error rate of just managing this audit process. And when you think about this, and you could, if you want to think of this as instead of pulling random samples, you're going to pull all of them, and you're going to do manual tally entry. You're not going to calculate risks. And one thing that goes away is the manual, this innocent fix-up error does not apply in a full hand count. You can fix things as you go. It doesn't hurt. The reason you can't do that in a sampled audit is because the samples that you pull are supposed to be representative of the rest of the election. And you can't fix those and say, well, I fixed that one, now it's fine. The analogy is the pot of soup they use. You stir up this pot of soup. You don't have to taste the whole thing to see if it's the right seasoning. You stir it up really well, take a teaspoon out, see if it's seasoned right. But if it's not, you don't get to re-season the teaspoon and then say, yeah, okay, it's seasoned right. That didn't re-season the rest of the pot. Okay, that's the innocent fix-up, where you just re-season the teaspoon. And when they do that, this is what they were doing in Los Angeles. It was routine, and it would always say, yeah, all the samples were good. No problem. Yeah, the samples were good. Now, if you do a full hand count, though, it doesn't matter if you fix each teaspoon as you taste it and then put it in the other pot. It's okay. By the time you get done, the new pot is seasoned right. And so, of course, we assume you could take salt out, of the soup if it's too salty, but that's not, and you're not ever actually consuming the soup as you do it. You can taste it and not hurt it. So anyway, this is better if you do the full hand count, because you don't have this problem. And that's why it was pretty smart of Georgia, because they did the full hand count of all of the ballots in the count and the state for that presidential election. You really couldn't, I mean, you could complain about different aspects of it, but you couldn't get involved in saying, well, they didn't randomly sample it well enough, that goes away. If they find mistakes and they fix them, that's okay. That fixes the result as you go, and then the result is correct at the end. So it's really better in many respects just to do away with this sampling methodology if you have a really close thing, and there could be issues. So going back to my point, though, is that 0.48% to 2.1%, that's only the tallying part of it. And it doesn't include all of the management of basically securing the ballot storage and pulling the right ones, getting the right samples, getting them pulled. And this applies also if you've got a full hand count. You have to pull one batch and only do it once, count it once and keep track of them all. So it is, it's certainly, but here's a reality. If you look back to the history of elections, like as soon as computers were available to help these election officials with this process, it was one of the very first applications for using computers. I mean, it was 1962 when they first started using electronic voting machines. They had other machines before that, the mechanical ones and so forth. And because it actually is difficult for humans to do this, we get too bored and distracted, and it's hard for us to take counts. So I just wanted to go over that. Now let's go back to your questions.